Welcome back, Chemistry 30. Hopefully you had time to go through the questions here, the redox questions. So we'll take a look at the first few here. So sulfur is +6. I think it's nitrogen here is +3, and bromine is +5. So if we take a look here, oxygen is always -2 because it's the closest to fluorine, so that's a total of -8. Sodium and hydrogen are each +1 because they're equal to their charges. So that means sulfur must be +6, so this whole thing adds up to be 0. We only have one sulfur, so it's equivalent to what I have down here. Oxygen, -2, times 4 is -4, but we notice here this ion must have a charge of -1, so all the nitrogen must be +3. And I only have one nitrogen, so each nitrogen is +3. Over here, again, oxygen is -2, 2 times 3 is -6. I need to have a charge of -1 though, so bromine must be +5. Looking at the ones down here, nitrogen is the most electronegative element, so its oxidation number is equivalent to its charge, -3. Potassium is +1, equivalent to its charge, which means carbon must be +2. I think I have this one wrong here, so we're asked to find the nitrogen here, so yes, it's -3. This one's a tricky one because we have to look at it in terms of hydrogen. Hydrogen is always +1, for recall, so +4, which means nitrogen combines to give -4, but I have two of them, so each one's -2. And over here, oxygen, -2, so it's 6. We have to have a charge of -1 there, so my nitrogens must be +5. And last one over here, fluorine, the most electronegative element, has a charge of -1. I have 3 of them, so it's -3, so nitrogen must be +3. These ones at the bottom are tricky, but if you take a look at what the compounds are, for example, this one here has to be iron 2 chromate because we have one iron for every chromate. Chromate is -2, so that tells us that the iron is +2. Gold 3 selenate because you can see here that I need 3 selenates to balance, etc. And nickel cyanide, nickel is a charge of +2. So if you take a look at all the working here, oxygen of course gives -8, iron is 2, so chromium is 6. I have 2 chromiums though, so each one must be +3. This one here, be careful here, each oxygen is 2, but in total I have 12 oxygens, so 12 times 2, -24. Each gold is +3, so they yield +6 overall. So the only thing left over is 18 here, such that we get 0 as a total charge. We have 3 seleniums, so 18 divided by 3 is 6. Nickel cyanide, nitrogen is -3, but I have 2 of them, so it's -6. Nickel is +2, so that yields +4 coming from the carbons. I have 2 carbons though, so each one must be +2. A little tricky. If you look here, determine the net change of oxidation number in each of these elements. So I'll kind of have all the working here for you. So carbon goes from 0 to +4, oxygen goes from 0 to -2, so here's the change that happens. And very similar to what we did previously, chlorine has a change of -1, zinc has a change of no change because it's +2 to +2, iodine from -1 to 0, so that's a +1 movement. Cadmium here goes from +2 to 0, so that's a change in the -2 direction. 0 or O doesn't change. Carbon goes from +2 to +4, so that's a change of +2. Looking here, which of these does not represent a redox reaction? So if you had a chance to go through this, figuring out all the oxidation numbers like we did previously, you can see here that no atoms undergo a change in oxidation numbers. Lithium, +1 to +1. Nitrogen, +5 to +5. So that is not a redox reaction. However, these ones are because they do undergo a change. Silver goes from 0 to 1. S goes from 0 to -2. Magnesium doesn't change. Iodine goes from -1 to 0. Bromine goes from 0 to -1. So those ones are redox reactions because they undergo an electron change. So to wrap it up, oxidation reduction reactions, a reaction in which electrons are transferred from one element to another, from one atom to another. So for an example here, potassium bromide combining with chlorine, you can see how that works out. Redox reaction, basically the same thing, so you can see the previous definition. Loss of electrons is oxidation, so sodium becoming sodium +1 and giving off an electron. Reduction is the gaining of electrons by an atom of a substance, so chlorine gaining 2 electrons to become that. Oxidizing agent is the substance that oxidizes another substance by accepting its electrons. So for example, potassium goes from 0 to +1. It was oxidized. What caused it to become oxidized? Bromine, because bromine accepted the electron from it. And lastly, reducing agent, the substance that reduces another substance by losing its electron to it. So bromine, you can see, goes from 0 to -1. Bromine is reduced. What caused that to happen? The potassium. Potassium is the reducing agent because it gave its electron to bromine so it could undergo reduction. Okay, there you have it. That's the end of booklet 20.1, Oxidation Reduction. We'll see you again.